We are continuing with improper integrals. Let's do other examples. Evaluate the integration minus infinity to infinity 17x times e to the minus x squared dx if it is convergent. This time, there is no lower bound and there is no upper bound. So what we have to do is we will break down into two pieces. Then you can break it down anywhere, any number here, but 0 seems to be convenient, and so I will break it at 0. So minus infinity to 0, 17 x e to the minus x squared dx plus integration 0 to infinity 17 x e to the minus x squared dx. So integration minus infinity to 0, 17 x e to the minus x squared dx. And then by the definition of improper integral in this circumstance, we will put t goes to negative infinity, and we put the indefinite number t as a lower bound and 0 as upper bound. So 17 e to the minus x squared x dx. So what we want to do is we want to do substitution method. So u equals minus x squared, then its derivative is minus 2x dx. So what happens here is x dx equals minus 1 over 2 du. So we are changing the variable, and so we have to evaluate at x equals t. Then u equals minus t squared. And if x equals 0, then u equals minus 0 squared, which is 0. So this is the information we will combine when we rewrite the integration. So limit t goes to negative infinity. Integration, the lower bound turned out to be minus t squared and upper bound was remaining as 0. And when we change that to u variable, 17 times e to the x squared will become u, and x dx becomes minus 1 over 2 du. And so that equals limit t goes to minus infinity. So minus 17 over 2, I'm just pulling this out. And then we consider the integration with e to the u. And then we have the same number, e to the u. and the lower bound was minus t squared, and upper bound is 0. So that is limit t goes to minus infinity, minus we are evaluating minus 17 over 2 e to the 0 minus e to the minus t squared. So limit t goes to negative infinity minus 17 over 2, and e to the 0 is 1 minus limit t. So it is, so just I'm writing the same thing. So limit t goes to minus infinity e to the minus t squared. So we just splitted the limit, but the first one was the number, and so we don't have to put the limit. So what we have to think about is the graph of e to the x. So this is y equals e to the x. Right. And so we want to evaluate this. So we have to think about the limit of minus t squared, where it goes. When we think about the limit of minus t squared, that will be minus infinity, right? So as t goes to minus infinity, t squared will go to infinity. So this one will become minus infinity. So e to the minus t squared can be written as 1 over e to the t squared. And then when t goes to negative infinity, this part will go to infinity. And if you follow through the graph, then that'll go up forever. So 1 over something will get smaller and smaller and will go to 0. Minus infinity. So let's continue. What does that mean? As t goes to minus infinity, e to the minus t squared will go to 0. And so this term will vanish, right? And so we have minus 17 over 2. Any question? And then that is integration 0 to infinity, 17 times x times e to the minus x squared dx. Then we have to write that down as t, limit t goes to infinity, integration 0 to t, 17 x e to the minus x squared dx. So this time what happens here is when you compare this integration and this integration, the only thing which is changed is this position, and t goes to infinity instead of t goes to negative infinity. And so we don't have to go through all the steps again. Instead, we will go to this step. So upper bound and lower bound are switched. So all we have to do is we have to switch these two terms, right? And so we get minus 17/2, and the limit this time t goes to infinity, e to the negative t squared minus 1. So we do the same thing. So in the previous problem, t goes to negative infinity, but that t goes negative infinity, but that negative number is applied to t squared. So whether t is positive or negative doesn't affect the limit of t squared, right? And so t goes to infinity will make this t squared goes to infinity again, and then 1/e to the t squared will get smaller and smaller because e to the t squared will get larger and larger, right? And so what I'm saying is this vanishes, and when we multiply these two together, that is 17/2. And then what we want to do is we want to think about combining those two, minus infinity to infinity, 17x e to the minus x squared dx equals integration minus infinity to 0, 17x e to the minus x squared dx plus integration 0 to infinity 17 x e to the minus x squared dx. So the first one is negative 17/2 plus the next one is 17/2 equals 0. So any question about this problem? So the next one is improper integral. So f is continuous on AB. This is a semi-open interval, and that is discontinuous at B. And so what we are thinking about is the different type of integration. The what we are thinking about is something like this. So there is an asymptote, and then at this point, at this asymptote, the function is not continuous. Then integration a to b f of x dx equals limit t goes to b minus integration a to t f of x dx if limit exists. So we are thinking about the area under this curve. So this line, this curve approaches this vertical asymptote, but it is discontinuous because that is undefined at B. So we are not thinking about the we are not thinking about from here to the left all the way down to the left. Instead, we are thinking about the point where the function is discontinuous. The second type is f is continuous on open interval, semi-open interval a to b, and is discontinuous at a. So then integration a to b f of x dx equals limit t goes to a plus integration t to b f of x dx if limit exists. So you know what I am talking about. This is this time the line is here. So whatsoever the reason is, the function is broken there. And then we want to think about the area under the curve from A to B. The function is not defined at A. And so what we are doing is we think about T here and then push it toward A. So that is from the bigger number. So I put plus sign here. That means T goes to A from the larger number. For this part, and the T was here, and the T is approaching B from the smaller number. And so I put minus sign here. So let's say F is discontinuous at the number C, where C is from A to B, and then integration A to B in f of x dx. And then we think about A to C, f of x dx plus integration C to B, f of x dx. So the third case looks like this. This is C, and this time, so whatsoever the reason is, the function look like this, and then we think about the area, this area. So this is A and this is B. And then since that is not defined here, so we have to think about the area, left side area and right side area. And so that's what I'm saying. So Let's do the example. Evaluate integration 0 to 1, 77 over x to the 5th power dx if it is convergent. Integration 0 to 1, 77 over x to the 5th power dx. So t goes to 0 plus, because this is discontinuous at x equals to 0, because the denominator is 0, then the function is undefined. The fraction is undefined. Can I see the? Yeah. So let me know after you copied everything. Are you ready for the next page, or do you need more time? So integration t to 1, 77 x to the minus 5 dx power. We want to apply the power rule. So that is limit t goes to 0 plus 77 times one more power, which is -4 over -4. It goes from t to 1, right? So we have t goes to 0 plus, so minus 77 over 4 times 1 minus 1 over t to the 4th power, and -77 over 4 plus 77 over 4, limit t goes to 0 plus 1 over t to the 4th power. So what is going on here is of course, this is a finite number. We have to evaluate this part, and t goes to 0. That means this denominator gets smaller and smaller, and that means the 1 over something is reciprocal, will go to infinity, diverge, right? And so adding small negative number doesn't matter. Anyway, it'll go to infinity. So we can say that that is divergent. Any questions so far? Are you ready for the next page? Evaluate integration 2 to 3, 32 over square root of 3 minus x dx. So obviously, we have to think about the substitution method. And what we realize is in this case, if the denominator is 0, then fraction is not defined. So this time, not the lower bound, the upper bound is undefined, right? And so if x equals 3, then 32 over square root of 3 minus x is undefined. (32 over square root of 3 minus x dx equals integration 2 to t 32 over square root of 3 minus x dx. So just this part came from this observation, right? And then limit t goes to 3 minus integration 2 to t 32 times 3 minus x to the minus 1 over 2 dx. So we can use substitution, but this is a very simple pattern of the integration. And so we will do it directly because we know how to do it. So this is limit t goes to 3 to 3 from the left. That is 32 times minus 1. So minus 1 times 3 minus x minus 1 over 2 plus 1 over minus 1 over 2 plus 1. So probably some of you are confused about why I multiplied minus 1. So do you know where it minus 1 came from? So minus 1 came from, I think probably it was better to do a straightforward method. So u equals 3 minus x, right? And so du equals minus dx, right? And so minus 1 came from here. U was 3 minus x. So 3 minus x was written here. And we apply the power rule. So we have to add 1 to the power, and we have to divide by the same number. But we didn't change the variable to u, so we still can keep the original one, 2 to t. Probably it was better to write to u from the beginning to go one more line. So is there anyone who is confused, still confused? Is that clear? So that is limit t goes to 3 to the negative 3 from the left, and minus 32 times 2 times 3 minus x to the 1 over 2 to 2t. So why is that? When we add them, we will get 1 over 2. 1 over 2 is in the denominator. When that is multiplied, we have to use the reciprocal and multiply in front of the numerator. Any question? You can ask me a question if you something is ambiguous. So let's keep on going. Then that is limit t goes to 3 from the left, minus 64 times square root of 3 minus t minus 3 minus 2 to the 1 over 2. And so that is minus 64 times limit t goes to 3 from the left, square root of 3 minus t minus 1. So because 3 minus 2 is 1. And that equals minus 64 times minus 1, because this one goes to 0 because t goes to 3. So 3 minus 3 equals 0, right? So that is 64. So any question?
Professor, can you go back to the last page?
Last page? Yeah.
So in that very last line, how did you come up with the parentheses square root of 3 minus t, like that whole last line?
Yeah. This one can be written as square root of 3 minus x, right? And then we have to plug in t here to get this one. And we have to plug in 2 here. And then we get this one.
Okay, you just plugged in the bounds. All right, that makes sense.
That's correct. Yeah. Do you have any other question? If something is ambiguous, you have to clarify. And that can be just a small little things. And but if there is a glitch, then you feel like everything is foggy. Evaluate integration minus 2 to 3, 40 over x to the 4th power dx if it is convergent. This time situation is a little bit different because we are thinking about the function which is symmetric with respect to y-axis. And we are thinking about minus 2 to 3. So this continuous point is not occurring at the boundary. Instead, it is occurring in the middle. So there is a point where the function is undefined. So we have to break this integration into 2 pieces so that the integration doesn't, the the range of the integration doesn't contain the point where the function is discontinuous. So let's do that. -2 to 3, 40 over x to the fourth power dx. Then, as I said, we will break in the middle. So -2 to 0, 40 over x to the fourth power dx plus integration 0 to 3, 40 over x to the fourth power dx. So we will apply the general principle we have been applying for the first and second. Integration -2 to 0, 40 over x to the fourth power dx. So limit t goes to 0 minus integration -2 to t, 40 times x to the -4 to the dx. So we are thinking about limit t goes to 0 minus from the left. So we are thinking about this part. Then we have 40 times x to the -3 power over -3 from -2 to t. Any questions so far? So I just applied the power rule, and so it becomes 1 less, and then the same number divided by. And then to conclude the problem, we have to take limit for both terms. And after we plug in, so 40 times 40 over 3. So it should be -40 over 3. And then it becomes 1 over t cubed minus 1 over -2 cubed. So what I did here is x to the -1 power is 1 over x cubed, right? And so t is t cubed, and then I plug in -2 to the lower bound. So we are applying the limit to the first one and the second one. Second one is a number, and that is not involved with t, so we don't have to care about that. But the problem is when we think about limit t goes to 0 minus 1 over t cubed, that goes to negative infinity because this is a negative number. So from t approaches from the left. So negative numbers. So this part would diverge to negative infinity, but negative number is multiplied. And so we don't really care about this part because we already got infinity. So it just it diverges to infinity. So it is just diverging. Any question? So 7.8 is finished, and 8.1 is the arc about arc length. I feel like if I explain the concept and then probably you will forget it when you come tomorrow. And also I may have to be in rush. So I think probably it is the good point to finish the lecture here. And if you have any question, then you can remain and try to clarify things. Otherwise, you can leave.